Currently, most signal generators on the market are single-channel or dual-channel. However, multi-channel signal synchronization output is sometimes required in testing. But multi-channel signal generators are expensive. Today, I will introduce a low-cost method, using multiple dual-channel signal generators to achieve multi-channel synchronized output or fixed-phase output. Required instruments: oscilloscope, 2 dual-channel signal generators. 4 channels are used as signal outputs. The rear panel is configured for external trigger synchronization and clock synchronization to achieve multi-channel synchronized output. Connect the sync output of the first unit's CH1 to the sync input of the second unit's CH1, and the sync output of CH2 to the sync input of CH2. Connect the clock sync of the first unit to the clock sync of the second unit. This achieves synchronization between the two units. Set the output source of the signal generator, with the output frequency of each channel set to 2 kHz. Click Burst. Set the trigger source for channels 1 and 2 to external, and set the type to infinite cycle. Click Utility. Set the clock source to external. Connect to the oscilloscope using BNC tables. Turn on the output of the signal generators. Click Auto Scale. The signals of the 4 channels are in phase and triggered simultaneously. Adjust the signal, basically achieving multi-channel synchronized output. When adjusting signal parameters, the phase parameters need to be manually readjusted set to the same phase. If you want the 4 channels to have different phases but with fixed phase relationships, how should you set it? Channel 1 has a 90-degree delay compared to Channel 2. Channel 3 has a 90-degree delay compared to Channel 2. And Channel 4 has a 90-degree delay compared to Channel 3. For easier observation, set the signal to a square wave. Set the starting phase of Channel 1 to 0, Channel 2 to 90, Channel 3 to 180, and Channel 4 to 270. The square waves of the 4 channels are very clear. Starting with Channel 1, Channel 2 has a 90-degree delay relative to Channel 1, Channel 3 has a 90-degree delay relative to Channel 2, and so on. The above describes for channel synchronized output or for channel output with fixed phase signals.